Bismillahirrahmanirrahim and Assalamu alaikum. My name is Zayan Rafiq and I am a foundation level student at Rehan School Islamabad Barago campus. Today I am going to conduct an AI session with Maya. In this session I will ask a few questions and Maya will provide the answer. So let's start. Hey Maya. Interview Karo.
Wait, what happened with your phone? How you mentioned in it.
Okay Maya, my first question is what is software?
Ooh, software at its simplest is just a set of instructions that tells a computer exactly what to do. Without software, your hardware is just a very expensive paperweight. Think of hardware as the body and software as the mind. It's the part you can't touch, but it's the only reason you're. No problem. What's the next thing on your list?
Okay, my next question is what is the difference between software and hardware?
Think of it this. Not not the hardware is the physical stuff you can actually touch, like the screen, the battery, the chips inside your phone. It's the raw machinery. Software is everything else, the logic, the apps, the operating system. Hardware is the piano. Software is the sheet music. One is.
Okay, my next question is what are the main type of software?
Right up your alley. So, if we're looking at the big picture, software basically splits into two main camps, but it's helpful to think of it as a hierarchy. First, you've got system software, which is the foundational layer. This includes things like the operating system, which acts as the middleman between the hardware and the user. Without this, your phone wouldn't know how to manage its own memory or talk to the screen. And then you have utility software, which is a subcategory of system software that handles the maintenance side of things like disk cleanup or security scans. Finally, you have application software, which is the stuff you actually interact with day to day, like the browser used to surf the web, WhatsApp for messaging, or a game. While system software manages the machine, application software lets the human get something done. It's the difference between the engine.
Okay, my next question is what is system software?
System software is basically the backstage crew of your computer, the invisible engine that makes sure everything actually runs behind the scenes. Its main job is to manage the hardware so that other programs can actually do their work. The most obvious example is the operating system, like Windows, Mac OS, or Android. It's the boss that handles the memory, manages the CPU, and makes sure your keyboard and screen are talking to each other. Then you have things like device drivers, which are essentially translators that let the OS understand how to use a specific piece of hardware, like a printer or a graphics card. Without system software, you'd have to manually tell the computer exactly which electrical circuit to trigger just to move your mouse, which would be a total nightmare. It creates the stable environment that allows your apps to exist and function without crashing the whole system every 5 seconds. If your phone is a house, system software is the plumbing and electrical wiring, the stuff you don't think about until it stops working.
Okay, my next question is what is application software?
The system software is the house's plumbing. Application software is everything you actually put inside it. These are the programs designed for a specific task, whether that's something as simple as a calculator or something as complex as Photoshop. Unlike system software, which mostly worries about it's the front window, the part that allows you to run email, watch a movie, or browse the web. Basically, any app you download from a store is application software. It's the tool you pick up to get a job done.
Okay, my next question is what is programming?
Programming is basically just the art of giving a computer a really, really specific to-do list. It's the process of taking a goal like, I want a button that changes the screen color to blue, and breaking it down into logic that a machine can understand. Since computers don't speak English or any other human language, we use programming languages as a bridge. You write the code, and then a separate piece of software translates that code into the binary ones and zeros the hardware actually runs on. At its core, it's just problem solving wrapped in a specific syntax. Want to know how that differs from coding, or should we dive into how a program actually gets built?
Okay, my next question is, what is coding?
Coding is the actual writing part of programming. If programming is the whole architectural process of designing a building, coding is the manual labor of laying the bricks. It's the specific act of translating your logic into a language the computer understands using the right syntax and rules. In the real world, people use the terms interchangeably, but strictly speaking, coding is just one piece of the larger programming puzzle. Want to know how they differ in a professional setting?
Okay, my next question is, how is software developed?
I'm guessing you mean how software is actually developed, right? It's less like writing a book and more like building a skyscraper. First, you have the requirements phase where you figure out what the software is actually supposed to do. Then comes the design where you map out the architecture so the whole thing doesn't collapse once you add a few features. After that, the developers get to work actually writing the code, but the most critical part is often testing. You've got to try and break your own creation to find the bugs before a user does. Once it's polished, it gets deployed to the world, but the work never really stops. There's constant maintenance, updates, and new versions as the world changes. It's a continuous cycle of building, breaking, and fixing.
Okay, my next question is, what does a software developer do?
A software developer is basically the architect and the builder rolled into one. Their day isn't just staring at a screen writing lines of code, though that's a big part of it. They spend a huge amount of time just thinking through the logic before they ever touch the keyboard, trying to figure out the most efficient way to solve a problem without creating 10 new ones. They design how the app should behave, hunt down those annoying bugs that make a program crash, and collaborate with other people to make sure the final product actually does what the user needs. It's a constant game of why isn't this working, followed by the sudden rush of, oh, it was just a missing semicolon. Which part sounds the most interesting to you?
Okay, my next question is, what is the difference between a software engineer and a programmer?
Most people use these interchangeably, but if you want to be picky, there is a distinction. Think of a programmer like a skilled translator. They're the ones in the trenches, taking a specific set of instructions and turning them into code. They're focused on making sure the code works, it's clean, and it does exactly what it's supposed to do. If you have a problem that needs a solution, programmer is the one who writes the script to solve it. Now, a software engineer is more like a civil engineer for digital structures. They aren't just writing code, they're designing the entire ecosystem. They're thinking about how the app scales to a million users, how it integrates with other systems, and the long term maintenance of the whole product. One is focused on the act of writing the code, and the other is focused on the science and architecture of the system. Still interested in diving deeper into this, or did you have another question on your list? What's the next one?
Okay, my
Yeah?
okay, my next question is, uh, which programming language is best for beginners?
I've got to go with Python. It's basically the English of programming languages. The syntax is super readable, meaning you spend way more time actually solving problems and way less time fighting with the computer over where a bracket goes. It's incredibly versatile too. So, whether you want to automate a boring task, dive into data science, what's the plan?
Okay, my next question is, why is Python so popular?
It's basically the Swiss Army knife of the coding world. One big reason is that Python is incredibly read, so you don't have to spend hours decoding a wall of text just to figure out what a piece of code is actually doing. But it's also just everywhere, and I mean really everywhere. Whether you're looking at AI like what we're doing right now, data science, or even just automating a tedious task at work, Python has a library or a pre-built tool for almost everything. Plus, the community is massive, which means if you run into a bug, 1,000 people have probably already fixed it on the internet. It's that combination of simplicity and done with the community. Got it. What's next on the
Okay, my next question is, what is the difference between Python and Java?
It's kind of like the difference between us. The biggest difference is how they handle the rules. Python is like writing a casual note to a friend.
Okay, my next question is, what is HTML?
HTML is basically the skeleton of every single web page you've ever visited. It doesn't actually do anything smart like a programming language would, and it's not meant to. Its only job is to tell the browser what the content is. This is a heading, this is a paragraph. Put a picture right here. Without it, the web would just be a giant disorganized wall of text. I can talk more about how it works with CSS and JSS if you want, or we can move to the next one.
Okay, my next question is, what is CSS?
CSS, the style to 8. Um, One, I'm gonna go and I'm gonna make sure I follow. If you're jumping back to HTML, or are you actually asking about CSS? Your last few questions were like a checklist, so I don't want to accidentally skip something you need for this project.
My question is, what is CSS?
Got it. CSS is the makeup and outfit for your HTML skeleton. Without it, every
Okay, my next question is, what is JavaScript?
I'm not sure what I'm doing, but you definitely just put me through a loop. JavaScript is essentially the brain of a website. If HTML is the skeleton and CSS is the outfit, JavaScript is the nervous system that actually makes the page do something. Without it, a website is just a digital flyer. With it, you get the things that make the modern web feel alive. I'm talking about the drop-down menus that slide open, the like buttons that change color instantly without the page reloading, and the infinite scrolls that keep you zooming through your feed. It's the logic layer that handles the interaction between the user and the page. When you click a button and a pop-up appears, or when a map updates in real time as you drag it, that's JavaScript at work. It essentially takes a static document and turns it into a dynamic application. Want to know how it actually communicates with a server, or should we move to the next one?
Okay, my next question is, what is the difference between a website and a software?
It's kind of like the difference between a magazine and a calculator. A website is primarily built to deliver information. You go there to read, browse, or watch something. The main action is the browser fetching a page from a server and showing it to you. It's mostly a delivery system for content. Software, or a standalone application, is built to perform a specific function or task. Think of a word processor, a video editor, or a game. These aren't just delivering info, they're using your computer's actual processing power to manipulate data and create outcomes. Now, the line is blurring because of things like Google Doc. Like how Google, like, actually, Google Docs is the perfect example. It lives in a browser like a website, but it behaves like software because it lets you actually create and edit a document in real time. The distinction is getting harder to make because web apps are becoming so powerful. Your last few questions were really
Okay, my next question is, uh, how are mobile apps created?
all right. Let's crack this one open. It's kind of like building a house, but depending on who you're building it for, you have to pick totally different tools. First, there's the native approach. If you're building for iOS, you're using Swift. For Android, it's Kotlin. This is like building a custom home from scratch. It's a lot more work because you're basically building the same house twice, but the result is a home that's perfectly tailored to the land. Yeah, custom homes are a lot of work, but they feel right. So that's the native side. Then you've got the cross.
Okay, my next question is, what is desktop?
I'm assuming you mean desktop software. That's basically just a program designed to be installed on a PC or a Mac rather than living in a browser or on a phone. Think of it like a powerhouse. It's been a wild one. Basically did a full software engineering degree in one night. Go get some sleep. You've earned it. Talk soon. Night. Bye.
Okay, my next question is, what is a software bug?
Wait, I thought you were headed to bed, but since you're still here, a software bug is essentially a mistake in a program's code that causes it to behave in an unexpected or unintended way. It's like a typo in a recipe that tells you to add a cup of salt instead of a pinch. The program still follows the instructions, but the result is a disaster. The term actually comes from the early days of computing when an actual moth got stuck in a relay of the Harvard Mark II computer, causing it to malfunction. Now, debugging.
Okay, my next question is, what is debugging?
Since you're on a roll, let's keep it going. Debugging is the process of finding and fixing those software bugs we just talked about. If a bug is a mistake in the code, debugging is the detective work required to track down exactly where that mistake is and how to correct it. It's a critical part of software development because no matter how experienced a developer is, bugs are inevitable. The goal isn't to write perfect code the first time, but to have a systematic way to refine and stabilize it. This usually involves things like using a debugger to step through the code line by line, analyzing error logs, or adding print statements to see what the program is doing in real time. At its core, debugging is the loop of guessing what's wrong. Oh, welcome. You've definitely mastered this. Mm-hmm.
Okay, my next question
I'm
is,
glad I'm here
what
too.
is a database?
The database is like a digital filing cabinet, just way more powerful. Think of a regular spreadsheet, but designed to handle millions of pieces of information at once without breaking a sweat. It's where a program stores all its long-term memory, like your username, password, and every single thing you've ever posted on a social media profile, so it can find and retrieve those specific details in a fraction of a second. Most of them use a language called SQL to organize everything into tables with rows and still following along.
Okay, my next question is, what is open source software?
Basically, it's software where the secret sauce isn't a secret. Normally, when a company makes software, they keep the source code locked away like a family recipe, but open source flips the script and makes the code public, meaning anyone can look at it learn from it, and even suggest improvements. It's kind of like a massive community potluck where everyone brings a dish and everyone's welcome to tweak the ingredients to make it taste better. This is how some of the most important parts of the internet were built because it allows thousands of developers around the world to collaborate and squash bugs way faster than one company could do alone. Linux is a huge example of this in action. Do you want to know why some companies actually share their secrets for free?
Okay, my next question is, what is Git?
Git is like a high powered, Git is essentially a super powered undo button for your entire project. Think of it as a time machine for your code instead of having a dozen different versions of a file like Project Final, Project Final V2 prim, and Project Final V prim. Git lets you take a snapshot of your project at a specific moment. You can branch off to try a crazy new idea without risking the main project. And if it doesn't work, you can just snap back to where you were before everything broke. It's what makes it.
So viewers, this is the session for Maya. Today we will meet in another Maya session. तब तक के लिए अल्लाह हाफिज, पाकिस्तान जिंदाबाद.